Hello, my name is Jared Skeens, and welcome to the Zoom room. Today I'd like to cover Statistics 1, Data Representation, Location, and Spread, Part 3, the histogram. But before we get into the histogram, we need to discuss a few concepts first. And one of those is the difference between discrete data and continuous data. So when you're talking about discrete data, you're talking about data that can only take particular values within a certain range. So let's say you're talking about months of a year. Well, if you're talking about months, as in the whole month, well, you can have 1 month, 2 months. Now, technically, you can have 2.5 months, but if you're dealing with months as individual segments, then you either have 1, 2, 3, 4, so on, up to 12. So the range would be like 12 months in 1 year. So out of those 12 months, you have a certain number of months. They are discrete. In other words, you're treating them as an individual packet, and it has to take particular values. So specific values, here's some of the description, has to take specific values, and it has gaps, meaning there's not allowed like those fractions, like 3.5 months. You're either 3 months or 4 months. So there's gaps in between the discrete values. Whereas continuous means throughout the range, the data can take any value within that range. So this might be something like the length of a phone call, because you're dealing with hour, minutes, seconds. You know, it can take any length of a phone call, or height of people. Between any two people, there can be another person in between. So height does not come in discrete increments that, well, you have to be this height or that height. So it can take any value within the range, and there are no gaps. It doesn't mean that all the points are covered in the data set, but potentially any data point or a data point could be any particular value. Okay, so obviously if you have 5 data points, you can't take up all the possible values, but they could take any value within that range. So this is the difference between discrete and continuous. And we're going to see this concept throughout the Statistics 1 syllabus. So you need to really get a hold of it, because when we get to histogram graphs and cumulative frequency graphs, both of those require continuous data sets. Also, later on in statistics, when we get into probability distribution, there are some distributions that are discrete, and there's another one that we're going to look at that's continuous. So you really need to have this concept down in your mind of discrete versus continuous. Then another area that we haven't discussed yet is having grouped data. Grouped data means that your data point isn't standing alone as its own particular value. It's arranged into groups called class boundaries. So as long as you're within the group, then you're classified under that category. And so the F here being the frequency. So I just gave a very, very brief example to illustrate the difference between discrete and continuous by just giving you a 2-section class boundary chart. Normally, you'll get class boundaries will have 5 or 6 sections to it. I only put 2 on here to illustrate the difference. Notice our values here go from 0 to 9, and then from 10 to 19. Now this is a little tricky because our mind automatically connects the 9 to the 10, and we sometimes think that that's continuous. But actually this is discrete. We have 0 to 9, we have 10 to 19, and notice there is a little tiny gap between 9 and 10. There's no place for a data point that's 9.5. What do you do with the 9.5? It's not between 0 and 9, and it's not between 10 and 19. So you have to be careful of these class boundaries that look like all the numbers are covered, but there's actually little gaps between each grouping. So this is discrete. Whereas if you look over here, it says from 0 to 10 and then 10 to 20. The 10 is included in the first group, not included in the second group. This one is continuous because the ends, are right there on top of each other, the 10. You see the numbers repeat there. So that is your indicator that this is continuous. The 10 is included in this group, not in this one, but it allows for 10.1, 10.2, 10.3. Okay, so again, when you look at these class boundaries, the first thing you need to ask yourself, is it discrete or continuous? If it's continuous, you're okay, you can proceed. If it's discrete, you need to make a change because histograms and cumulative frequency graphs require continuous data. So to make this continuous, what you're going to do is you're going to fill in the gap. So halfway between 9 and 10 is 9.5. So you're going to actually call this 9.5. And whatever that halfway value is, you need to make sure you do it at both ends of your categories or your groupings. So even though this is a 0, you're still going to go back to negative 0.5. And on this end, even though it's the furthest to the right, you're still going to expand it up to 19.5. So whatever that middle value is, however much that you have to, make those middle meet so that there's no gap, you need to do that on both sides of each grouping from the beginning all the way to the end. So that's going to be the first thing that you look for is if you have discrete data, you make it continuous. Then, as you look at it, you see you have frequency. Frequency tells you how many data points fall within that grouping. So this says there's 10 data points that fall within the 0 to 9, and there's 35 data points that fall within the 10 to 19 grouping. Then when we get to histogram, an important formula that you need to memorize is frequency density. FD is frequency density, means how tightly packed are these data points. Well, how tightly packed they are depend on how much space they have. And that space is called the class width. So you take the frequency, how much, divided by class width, and that will give you the frequency density. So to find the class width, you need to take your furthest upper boundary and subtract your lower boundary, the upper boundary minus the lower boundary. You need to do this after you've converted it to continuous, not before. So this would be 9.5 minus a negative 0.5 means you have a class width of 10. So if you have 10 data points spread across a width of 10, that gives you a frequency density of 1. In other words, you average 1 data point per 1 unit of space. Over here, we have 19.5 minus 9.5 also gives you a class width of 10. Now your class widths might be the same, they might not. It's okay if they're different widths, right? So you still subtract the upper boundary minus the lower boundary. The class width is 10. So 35, which is how many data points you have, divided by 10 means you have a frequency density of 3.5. So an average of 3.5 data points per 1 unit of class width. So this is an important formula for you because the frequency density is going to be your y-axis on the histogram, okay? So your frequency density, that is your y-axis. So that's important. Sometimes the Cambridge questions might give you the frequency density, they might give you the boundaries, but they don't give you frequency. So you just work backwards. Here's frequency. So to find frequency, you multiply the frequency density by the class width. Just multiply class width to the other side, and you can figure out frequency. So 3.5 times 10 is 35. 1 times 10 is 10. Okay? Then one other thing that we need for our histogram information is how to find the average, this X with a bar over it. Hopefully you recognize that from your IGCSE material as being the symbol for the average or the mean. And normally when you're dealing with individual data points, you add up all the data points and divide by the total number, right? So hopefully that's prerequisite material. You already know that. But now when you come to class boundaries, how do we find the mean or the average when we can't see all the data points? They're grouped. So what we do is we take the sum of the frequency times the mid-class value. Remember, mean is like average, and average is generally around, the middle. Although average and middle are not always the same, what we're going to do is we're going to take the mid-class value. So if we take the mid-class value, 9 plus 0 is 9, divided by 2 is 4.5. So 4.5 is our mid-class value. 19 plus 10 is 29, divided by 2 is 14.5. So 14.5, I hope you can see that there. 14.5 is the mid-class value of this group. 4.5 is the mid-class value of that group. So taking this really small example, if we were finding the mean, we would add up the frequency times the mid-class value. So 10, here we have frequency 10 times 4.5, which is the mid-class value, plus, that's the summation sign, means you're adding it up, capital Greek sigma, and then 35 times 14.5, you add those together and you have the sum of your frequency. I put 45, but if we write it separately, it would be 10 plus 35, the sum of your frequency. So 10 and 35 gives us 45. So when you work this out on your calculator, you get a mean of 12.3 for this very small chart that I put here just as an illustration. So these two down here are some of the skill formulas that you need. And then discrete versus continuous is a concept that you really need to grasp. Like I said, it's important now, and it will be important later in the statistics book. So now that we've covered that, let's get to an actual example, and I'll set us up for that. Okay, for our first example, instead of doing it on the board, I'm going to actually show it to you. I've got it worked out on a digital copy. So let's go to the screen share and see what the question looks like. Okay, here is a a particular question on a past paper. You can see it comes from summer 18. And here it gives us the lengths, T-minutes of 242 phone calls made by a family over a period of 1 week and are summarized in this frequency table. So notice the length of the phone call in minutes. So this group is for phone calls that lasted less than or equal to 1 minute. There were 14 calls. From 1 to 2 minutes was 46 calls. From 2 to 5 minutes, 102 calls. 5 to 10 minutes is this A. We're going to have to calculate the A here. I already have it put in. And then 10 to 30 minutes, there were 40 calls, and they don't have anything listed more than 30 minutes. So the first thing that they want us to do is find the value of A. Well, your frequency has to add up to the total. So it says there's 242 phone calls, and so this lists all of them but one set. So we add them up. We take the 242, that's the total, and then there's 14 for that group, 46, 102, A, our unknown value, and then 40. So all of this on this side adds up to 202. Subtract that from 242, and so our A equals 40, meaning there were 40 phone calls between 5 and 10 minutes long. Now, before we get too far ahead, we want to look at the nature of our data. There's two ways you can look at it. One of it is by looking at the groupings. Notice the numbers overlap. This is from 0 to 1, including the 1, and then this starts at 1 again, but not including the 1 all the way up to 2. So since these numbers already connect, that means this is continuous data. So we don't have to make a change to our groups because they already are right up next to each other. There's no gaps. Another way you can look at it is conceptually, which is actually better for you to mentally get into your head, because later when we get to the probability distributions, they're not going to give you a table to look at. So you need to be able to understand it conceptually. So you look at lengths in minutes of phone calls. Can phone calls be any minutes within a particular range? In other words, can they be half minutes? This is a little different than like months in a year. For example, if you get paid a salary, maybe you only get paid once or twice in a month. So you count the months as units. You don't break them up. But with phone calls, you can have 1.5 minutes, 1 minute, 40 seconds, like that. So it can take any length between the 0 and 1. It's not specific values for it. So the length of a phone call can be any value within the range. So two different ways. Of course, the easier way when you have a graph is just to look at the numbers they repeat, meaning it's continuous. So now we go down and we have to calculate the mean. Well, in order to do the mean, remember the mean is average. You need the mid-class value, halfway in between each class. So to do that, you add the two numbers together, the upper and lower bound, and divide by 2. So 1 plus 0 is 1, divide by 2 is 0.5. 2 plus 1 is 3, divide by 2 is 1.5. 5 plus 2 is 7, divided by 2 is 3.5. 5 and 10 is 15, divided by 2 is 7.5. 10 and 30 make 40, divided by 2 is 20. So 0.5, 1.5, 3.5, 7.5, and 20 are the mid-class values. And here are the frequencies down here in our frequency row. So we take the 14, let's see if we can see both of them here together. So the 14 times the 0.5 plus the 46 times the 1.5 plus the 102 times the 3.5 plus the 40 times the 7.5 and plus the 40 times the 20. So this is summing up the frequency times the mid-class value, and then we take that and divide it by the total frequency, which we were given up here, the 242, and we divide that and we get 6.33 minutes. So out of this chart, the average is just over here into this fourth grouping. So notice it doesn't always land in the middle grouping, okay? So this 6.333 minutes or 6 1/3 minutes landed in the fourth grouping. So you can find which grouping it is in. You can do the same thing with quartiles. We talked about quartiles in the last two videos. And so out of 242, if you divide that by 4, which is going to give you 6.5. So, you know, or so it'd be, 60, not 6.5, 60. And so 4 60s is 240. So it'd be like 60 point something. And so 60, here's 40, 50, 60. This right here, right in there is your first quartile, right at the somewhere in here. You'd have to divide it out. Actually, it's probably a decimal, so it'd land over here in the third grouping, just barely. So you can do quartiles also and figure out which grouping the quartiles land in. But it doesn't ask for that here. You know, obviously, like the median would be 121. Well, 121, where does 121 land at? Well, also somewhere in here would be your median, because you already have 140, 150, 160 by the time you get into here. So the first quartile is just into it. Median is also here. So you can find those kind of things if it asks you for it. Now it says to draw the histogram. So there's two important things that you need. You need to make sure it's continuous on the x-axis, and that is going to be based on your class widths. That is going to be your x-axis, and the frequency density is going to be the y-axis. So remember, frequency density is frequency divided by class width. So the class width is 1. Up here, the class width is 1. Here, the class width is 3. Here, the class width is 5. Here, the class width is 20. So 14 divided by 1 is 14. 46 divided by 1 is 46. 102 divided by 3 is 34. 40 divided by 5 is 8. And 40 divided by 20 is 2. You need to do this first. Don't start graphing your histogram until you have your information ready. So the x-axis is right here, no problem there. But the y-axis is your frequency density. So figure that out first so you know how high your y-axis needs to go. So since 46 was the highest, I made my y-axis to be 50. And so I went by 5s. So each block represents 2. So notice in between 5 blocks was 10. So going by 5s, 5 blocks at a time for 10 values of y-axis. And notice, and I didn't write it, I should have, the label should be written here. I was looking to see if I put it up here, should be FD. You need to put the label. I did not put the label, I should have. So this should be FD for frequency density. And this down here should be time in minutes. So I should have a label down here. Make sure you put your labels because that is part of the points on your mark scheme. So this should be frequency density on the y-axis and time in minutes on the x-axis. And notice these are not bar graphs. Bar graphs have gaps between them because they're categorical. This is continuous. So each bar here connects to the next one. So 0 to 1. Notice out here is 5, 10, 15, 20, 25, 30. So on the x-axis, I'm going by 10 blocks. 10 blocks. So since this is 5, that means 1 is 2 blocks wide. Okay, so here we only have 0 to 1. So I made it 2 blocks wide. So 2 counts as 1 because 10 blocks is at my 5 spot. Okay, so 2 wide and 14 high. So notice going this way, I'm going by 1 block is 2. Going this way, 2 blocks is 1. So make sure your scale is consistent. So going on the y-axis, 2 blocks is 1. So 5 blocks makes 10. 6, 7 blocks makes 14. And then wide, 2 blocks is just 1. So here's the 1. Then the next one is also 1 or 2 blocks wide. So it was a width of 1 and a height of 46. The next one was a width of 3 and a height of 34. Notice at the top of each one, I'm writing the number. What this does is it makes it easier for the Cambridge grader to see what your intended value was. Let's say you are halfway in between 2 lines. But when you draw the line, the thickness of your lead and things like that, it might be a little difficult for the reader to know what exactly your value is. So if you put those values right above the bar, that way the Cambridge grader won't look at it too microscopically. They'll see, okay, that's roughly 2 bars high and it represents 2. Or actually, sorry, that's one square high, and that 1 square, you notice it's kind of hard. You might want to use a straight edge so that it's a little bit more straight. Mine kind of was obviously hand done. And so the 2 there helps the grader know what you intend and that they won't be too picky about your lines. Remember, you need to do this quickly. If you're a perfectionist and you have to have everything just right, it's going to take you too much time. You do probably want to use a straight edge, but you need to work quickly. This one was worth 4 points. Okay, that means you got like 5, 6-ish minutes, and that includes figuring out your class widths, your frequency density, figuring out what your scales are going to be, both the y and x-axis, and drawing it. So you need to work efficiently. Okay, so again, don't forget the labels like I did, and I highly recommend you put these numbers on top of your bars. Just helps for that. Okay, so that was this question here. Now let's get rid of that and let me set up for the next question. Okay, here we go with our next problem. What I'm going to do is screen share first so that you can see the question. It says the speed in kilometers per hour of 90 cars as they passed a certain marker on a road were recorded. Correct to the nearest kilometer per hour. The results are summarized in the following table. So they group them. If they were between 10 to 29, that was one group, 30 to 39, 40 to 49, 50 to 59, and 60 to 89. And you can see the frequency down here, and those frequencies all add up to 90. So it first says to draw a histogram, then it says to estimate the mean. So that's what we're going to do. I'm going to come back up here and we're going to look at the board. And so here I've drawn it or drew just the numbers on the board. So we have 10 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 to 69 with the frequencies 10, 24, 30, 14, and 12. Now the first thing we want to check, discrete versus continuous. Notice the numbers do not repeat, meaning there's a really tiny gap in there. What do we do with a 29.5? Now it says that these values are rounded. So 29.5 would have rounded up to 30. 29.4 would have rounded down to 29. So even though their system allows for the data, their groupings appear to be discrete because there's little gaps in here. So what we're going to do is we're going to fill those gaps in so that we're certain it's continuous. So notice halfway between 29 and 30 is 29.5. That means we need to do a 0.5 on each side of each grouping at the beginning and at the end as well. So 10 becomes 9.5. We have 29.5, 39.5, 49.5, 59.5, and then at the end, 89.5. So that's important to do, is to first of all establish the continuous nature of our data set. Then what you might want to do is you might want to create a couple of your own rows, one for class width, one for frequency density, and somewhere along the line you're going to want to do a mid-class value. So make sure you're using the right information for the right formula. Class width, 29.5 minus 9.5 is 20. Then we have 39.5 minus 29.5 gives us a class width of 10, and 10 again, and 10 again. And on the last one, 89.5 minus 59.5 gives us a class width of 30. Frequency density, remember, is frequency divided by class width. So 10 divided by 20 is 0.5, 24 divided by 10 is 2.4, 30 divided by 10 is 3, 14 divided by 10 is 1.4, 12 divided by 30 is 0.4. This is the frequency density, which remember is the height of your histogram. So when I look at that, I see the highest value is 3. So here I've made a very small histogram with, now this time I put my labels, frequency density for the y-axis. The x-axis is speed in kilometers per hour. They were marking the speed of the cars as they went by a certain point. So speed in kilometers per hour. And notice then it does not start at 0. So I put it at 9.5. If you're using lined graph paper, make sure you offset your bar slightly with your line graph paper, because your line is most likely going to be like 0, 5, 10 or something like that. So if you have something that counts as your 10, you need to offset it just a little bit, 9.5. Okay, so if you put your numbers down here below, that helps. 9.5. And remember, if you did have a 0 and you had to go back to negative 0.5, that means your bar actually can start to the left of your y-axis. So if you had a 0 here, meaning a negative 0.5 here, that means you need to start your boundary at negative 0.5, and so your bar will actually cover part of the y-axis. That's okay. But you need to make sure that these numbers match up with your continuous numbers up here. So 9.5, and they should be scaled properly. So in other words, this one is 20 class width, and then half of that is 10, 10, 10, and then 30 is the longest. So make sure your scale is correct. So that's your x-axis. The y-axis is the height. Now notice it's just 1, 2, 3. All we need is a height of 3. So 0.5 is halfway to 1. So that's where the top of the bar is. And notice I put 0.5. That way people don't have to guess what I mean by that. Then 2.4. Well, it's kind of hard to tell the difference between 2.4 and 2.5 unless you're using nice lined graph paper. You can make it more exact, but I still put 2.4 at the top. Then 3 is right at the 3. 1.4 is almost halfway between 1 and 2, and then 0.4 is just slightly below the 0.5. And again, I put the numbers on top of all the bars so that people don't have to scrutinize it and guess or maybe critique your graphing. So by seeing the numbers, it goes a long way to the person looking at it to know whether or not you did it correctly, or at least intended it to be correct if you're not using really nice graph paper. So usually the newer Cambridge papers, past papers, provide the graph paper for you, so you don't need to worry about that. Just use a straight edge. Don't forget your labels: frequency, density, speed in kilometers per hour. Make sure that you have no gaps between your bars. The heights is frequency density. The widths is your class boundaries based on the continuous numbers, not the discrete numbers. Then to find the mean, this is the mean here, you need the mid-class value. So to find the mid-class value, you add the boundaries together and divide by 2. So it's the middle. Add them together, divide by 2. So we get a frequency of 10 times the mid-class value is 19.5. 19.5 is halfway between 9.5 and 29.5, plus 24 times 34.5, plus 30 times 44.5, plus 14 times 54.5, plus 12 times 74.5. That is the sum of the frequency times the respective mid-class value. Then divide by the total frequency, which it said in the problem was 90 cars. So divide by 90, or you could add up these as well. You'll get 90, and you end up with a 44.6 kilometer per hour average, correct to 3 significant figures. So this, again, is how to do a histogram. They should be able to also give you the histogram, and you come up with, like I said, the frequencies. Remember, if you're solving for frequency, just take the class width times the frequency density. So if you have the frequency density, half times 20 is 10, 2.4 times 10 is 24, 3.3 times 10 is 30, and so on. So you should be able to go from the information to the graph, or the graph back to the information. And this then is the conclusion of our part 3 histogram. Again, as always, thank you for joining me, and I look forward to seeing you again next time.